Imagine a connection so deep, so strange, it defies our common sense. This is quantum entanglement, a central mystery of the quantum world. It puzzled the greatest minds, it continues to astound us. Welcome to the quantum puzzle, a journey into the unknown. Albert Einstein felt its oddness. He famously called it spooky action at a distance. This phrase captures its essence. Two particles linked across vast cosmic distances. What happens to one instantly affects the other. How can this be so? The universe holds deep secrets. This isn't science fiction, it's a proven quantum fact, a cornerstone of modern physics. Yet it feels like magic. A whisper across the void, a connection without wires or any known force. Understanding entanglement is key to unlocking deeper cosmic truths. Our exploration starts now. Prepare to question reality. The world at its smallest behaves in peculiar ways. Entanglement is perhaps the most baffling of these behaviors. It challenges what we think is possible, is real. Join us on this quest to grasp the ungraspable, the spooky heart of quantum. Our everyday world is familiar. Objects have definite properties. A ball is red or blue. It is here or there. Classical physics describes this. It works well for big things. But the quantum realm is different. Particles live in a haze of possibilities until measured, a truly strange way to exist. Entanglement pushes this strangeness further. Imagine two special coins linked in a quantum way. You flip them, send them to opposite ends of Earth. Before you look, each is neither heads nor tails for certain, just a potential. Only when you check one, does its state become real. Here is the truly odd part. The moment you see heads on your coin, you know instantly the other is tails. Even if it's light years away, faster than light could travel. There's no signal sent, no message passed between them, just an instantaneous correlation, a shared, hidden destiny. This defies classical intuition. How can one particle know the state of its distant twin without any communication? It's as if they are one, despite the separation, a single entity, spread out. This interconnectedness is profound. It hints at a reality more unified than we imagine. A truly weird, wonderful dance. Albert Einstein, a quantum pioneer, helped lay its foundations. Yet, he was deeply troubled by entanglement's implications. It seemed to violate his cherished principles of how the universe should work. He felt something was missing, a piece of the puzzle that we had not yet found. Einstein believed in local realism. Local means objects are affected only by their immediate surroundings. No instantaneous distant influences. Realism means objects possess definite properties, like color, even when we're not looking. Entanglement seemed to shatter both these sensible ideas. This was deeply unsettling for him. In 1935, Einstein and colleagues Boris Podolsky and Nathan Rosen devised a thought experiment known as the EPR paradox. It aimed to show that quantum mechanics was incomplete. They argued entangled particles must have hidden variables, predetermined instructions unknown to us that dictate their outcomes. For Einstein, spooky action was not a true description of nature's fundamental workings. He suspected a deeper theory would explain these correlations without such faster-than-light effects. He championed this view until the end of his life, believing reality was more solid, more local than quantum suggested. His doubts spurred crucial debates. For decades, Einstein's concerns remained a philosophical debate. Were there hidden variables, or was quantum weirdness real? Then came physicist John Bell. In the 1960s, a breakthrough. He transformed the discussion from philosophy into science, testable, experimental science, a pivotal moment for physics. Bell devised a theorem, a brilliant piece of reasoning. He showed that if local realism were true, as Einstein believed, then correlations between entangled particles would have limits. Quantum mechanics, however, predicted stronger correlations, exceeding Bell's limits. A clear, measurable difference. This opened the door to experimental verification. Physicists like John Clauser, Alain Aspect, and Anton Zeilinger conducted ingenious experiments through the 1970s and beyond. They created entangled particles, usually photons, particles of light, sent them in opposite directions and measured their properties. The results were astounding. Again and again, experiments confirmed quantum mechanics. The correlations were stronger than Bell's theorem allowed for local hidden variables. Einstein's hope for a more classical explanation faded. The spooky action was real. Entanglement was undeniably part of the fabric of reality. The universe is indeed strange. Section 5. Harnessing the spook quantum technologies on the horizon. Understanding entanglement is not just an academic pursuit, Its bizarre properties are now being harnessed for revolutionary new technologies. What was once a puzzle is becoming a powerful tool. The future is quantum, and entanglement is key to unlocking its potential. Quantum computing is one area. Classical computers use bits representing 0 or 1. Quantum computers use qubits. Thanks to superposition and entanglement, qubits can be 0, 1, or both simultaneously. Entangled qubits work together, solving problems far beyond the reach of current supercomputers. Imagine new drugs, materials. Quantum cryptography promises unhackable communication. If two parties share entangled particles, they can create a secret key. Any attempt to eavesdrop on the entangled connection would disturb the system, instantly alerting the users. Perfect security, guaranteed by physics. This is already being tested. Then, there's quantum teleportation. Not of people like Star Trek, but of quantum information. The state of one particle can be transferred to another distant particle using entanglement. The original state is destroyed, and a perfect copy appears elsewhere. This could be vital for quantum networks of the future, linking quantum computers together. The possibilities are immense. Section 6. Weaving the cosmos entanglement's universal threads. Entanglement's influence may stretch far beyond new technologies. It might be fundamental to the very fabric of space and time itself. Some physicists now suspect that entanglement is not just a feature within space-time, but that space-time itself may emerge from entanglement. A truly mind-bending idea. Think of the universe as a vast quantum web. Entangled particles born together in the Big Bang could still share hidden connections across billions of light-years. This interconnectedness might explain some cosmic mysteries. Perhaps it plays a role in the structure of galaxies or the nature of dark energy. These are active areas of search. Even black holes, those enigmas, might be understood better through the lens of entanglement. The information paradox, for example. What happens to information that falls into a black hole? Some theories suggest entanglement between particles inside and outside the black hole could hold the key to resolving this deep puzzle. Stephen Hawking explored such ideas. If entanglement is truly a building block of reality, it means the universe is far more interconnected than we ever imagined. Not just a collection of separate objects and forces, but a holistic system where distant parts can be intimately linked, instantly correlated. This changes our cosmic perspective. We are part of this web. Section 7. The unfolding mystery: what entanglement might yet reveal. Despite decades of research and stunning experimental proof, quantum entanglement remains deeply mysterious, profoundly puzzling. We can describe it mathematically, we can use it in labs, but what does it? What is the true nature of this instantaneous connection? This is a question that still keeps physicists awake. How does entanglement fit with Einstein's theory of gravity, general relativity? These two pillars of modern physics describe the universe on different scales. Relativity for the very large, quantum mechanics for the small, but they are not yet fully compatible. A unified theory is the ultimate goal. Entanglement might bridge this gap. Are there deeper layers to reality that we have yet to uncover? Could entanglement be a window into these hidden realms? Some speculate about connections to consciousness or even the fundamental nature of information. These are highly speculative, but the mystery invites bold thinking, new ideas. The search for answers drives us. The story of entanglement is far from over. Each new discovery seems to open up more questions, more avenues for exploration. It challenges our deepest assumptions about space, time, and causality itself. This is the hallmark of a truly fundamental concept. Its depths are yet unplumbed. The mystery continues to beckon. Section 8. The journey continues. Embracing the quantum frontier. Quantum entanglement is more than just a curious phenomenon. It is a profound statement about the nature of reality. It tells us the universe is stranger, more wonderful, and more interconnected than our everyday experience would ever lead us to believe. This realization is inspiring a call to further exploration. The quest to understand this spooky action fully is one of the great adventures in modern science. It pushes the boundaries of human knowledge and ingenuity. It requires us to be open-minded, curious, and persistent. To embrace the weirdness and follow where nature leads, even into uncomfortable territory that challenges our intuition. What future discoveries await? What new technologies will emerge? How will our understanding of the cosmos evolve? Entanglement holds clues to these grand questions. The journey of discovery is ongoing, vibrant, exciting. Each experiment, each theory brings us a little closer to grasping its full meaning, a truly collective endeavor. So, let us embrace the quantum frontier with awe. Let the mystery of entanglement fuel our curiosity always. The universe is whispering its secrets to us, if we are brave enough to listen, to explore. The journey into the quantum is a journey into ourselves and our place in the cosmos. The adventure is just beginning, the best is yet to come.